sharpened up. I hadn't gone through. I know what our lesson's about. I just haven't gone through it in a while. So we'll kind of be looking at this together this morning. And anyway, what is it? 12:52. We'll give another minute or so, see if anyone else joins us, because we're missing a lot of folks right now. We're missing like what, 12, 13 people? Yeah, we're missing quite a few. But anyway, I'm gonna have a busy spring break. I'm gonna go to Williamsburg, Virginia next Monday and stay there, come back on Thursday, and that's with my drug company again that I was just on the Zoom meet with. So they're flying me out to their headquarters. And then after that, when I get back on Thursday next week, we're going to move into our house next Friday. Well, that's the plan anyway. So it better not change. We're moving in even if we're sleeping on the floor. So but they are finishing up our cabinets today. Wednesday, they're supposed to bring our countertops in, put the countertops, then they can do the sink and the stovetop and all those other things where they get the countertops in. And the kitchen will fall into place. So if the kitchen's in place, that'll help a lot. And our bedroom's ready. The only thing left is our bathroom shower. It's almost done, but it'll certainly be done by next week. And so that's our bathroom and bedroom and kitchen. That'll be the main areas. If there's anything else we're still working on, it won't be 100% when we move in. There'll still be work to be done, but it won't have to be just us living somewhere else though while it's happening. So a lot of stuff left to be done outside the house, and they can work on that whenever. So no hurry on that. They just get us in, we'll be happy. All right, how are we doing? We got 24 of us now. We're still missing 11. All right, glad you made it. Well, we got 25 of us. I think we're gonna have to get started just because I don't know how long it's going to take today. Let's see. Let's pull up our screen. Going to our grade screen, we should have a whole bunch of matrices behind us. Yes, Matrix Quiz 2 was due yesterday, so that's what last week was. So you should be up to Module 6. Hopefully you've got everything turned in up here. If not, this is the place to look. Go to the grade screen, see if there's any missing assignments there, and move on from there. But we are just one assignment each week. We're going to take it at kind of an easier pace because this is dealing with rational expressions that we need to slow down and take some time on to make sure we do this right. We're going to look at simplifying rational expressions this week. Then we'll have spring break. When we come back, we'll talk about discontinuities and asymptotes and solving. And there's some interesting things with rational expressions. A little different. We don't spend enough time in algebra looking at rational expressions. So that's why we're going to take these kind of slow, just one lesson, one assignment per week for the next 4 weeks or so. But let's go to 6.01 and see what we can dig in here and learn. I'm going to close this matrix folder. Glad to get all that behind us. There was helped a lot of grades. A lot of you guys really raised your grades with all that good stuff. So I'm happy to see that. All right, Module 6. Simplifying rational expressions. All right, start with a strong foundation. In order to build a strong house that will stand the test of time and the elements, the house must have a good foundation. Now it is time to build a strong understanding of rational expressions using the foundations of fractions and factoring polynomials. It's kind of combining these skills that we developed in the past. So we're going to learn how can rational expressions be rewritten in a simplified form. So let's dig into that. Using fractions, a great place to start because rational expressions are fractions, except for instead of like 2/3, it'll be something like 5x plus 35 over 5x. It's using polynomials in the numerator and the denominator, rational expressions. So I said we're going to take it a little slower. They'll still work the same way fractions work. So if you find yourself stuck, think about how you would simplify or solve using fractions, and it'd be the same steps. So rational expression is a fraction with a polynomial in the numerator and denominator. And there's two examples right there. X squared minus 6x minus 27 over x minus 9 is a rational expression. So, for example, let's start with the fraction of 4 over 8. Well, and then think about another more simplified way to write this, and hold that in your brain, right? Starting with 4 over 8, the numerator and the denominators can be factored, right? Because both the numerator and the denominator are divisible by 4. So if we factor a 4 out, 4 over 8 becomes 4 times 1 over 4 times 2. 4 over 4, if you're dividing 4 by 4, that's just 1. So those kind of cancel out because it's just like multiplying by 1 when you have 4 divided by 4. So that just leaves 1 divided by 2, or 1/2. So when we see 4/8, we think 1/2 because we do a lot of this in our head about the 4 over 4 part. But that's really the way it works. We just factor it to 4 times 1 and 4 times 2. And then 4 divided by 4 is just 1. Does this match the answer you had in your brain for 4/8? Hope so. All that was required was just to factor out the greatest common factor, which the greatest common factor was a 4. Rational expressions are exactly the same system, same manner. This may take a few extra letters thrown in, some X's and Y's or something. So factoring, the next skill foundation. Factors are numbers, variables, or a combination of both that multiply to be some product. You know, like 5x, the factors are 5 and x. 5 and x are the factors of 5x. If we have 6 plus x and 1 minus x, those are factors of 6 minus 5x minus x squared. They're just binomial factors instead of individual factors like 5 and x. So you look for the greatest common factor. That's the largest factor by which each term is divisible. So if we have 3w squared plus 27w plus 15, we can take a 3 out because 3w squared, 27w, and 15 all are divisible by 3. So that factors out to 3 times w squared plus 9w plus 5. Difference of squares. Remember, we looked at that in the past. A squared minus b squared factors to a plus ba minus b. So we may use that in some of this factoring. X squared minus 9 is x plus 3, x minus 3 as an example of this a squared minus b squared. Perfect square trinomials. So this is when it's the expression consists of 3 terms, and the first and last terms have to be perfect squares. And the middle term is twice what it is. Like if you have a squared and b squared, the middle term would be twice times a times b. And that would factor to be a plus b squared. That's a perfect square trinomial, so it factors into a binomial squared. For example, if you have r squared plus 12r plus 36, r squared is a perfect square, 36 is a perfect square, and if you took a times b, r times 6, and multiply it times 2, you get 12r. So this is a perfect square trinomial that factors to be r plus 6 squared, or r plus 6 times r plus 6. If you have a minus, the only thing that changes is you have the minus 12r instead of plus 12r, and that changes our binomial to an r minus 6 instead of r plus 6. Factoring trinomials. So this is really all review stuff here that we're going to be using in talking about rational expressions. If we factor a trinomial, you have x squared minus 8x minus 20. We figure out what are the factors of negative 20. Could be negative 1 and 20, 1 and negative 20, negative 2 and 10, 2 and negative 10, or negative 4 and 5, and 5 and negative 5. Any of those multiply together. But when they add together, we need them to add together to be negative 8. So these add together to be 19, negative 19, positive 8, negative 8. So we use 2 and negative 10. So this factors to be x plus 2, x minus 10, the factors of x squared minus 8x minus 20. We can do factoring by grouping. We do that before. You have 3x squared plus 8x plus 4. You take the 3 times the 4 because there's a coefficient on the x squared term. Find the factors of 12. You need the ones that multiply together to be a positive 12 and add together to be 8. So in this case, 2 times 6 multiplies to be 12, and 2 plus 6 is 8. So then you rewrite this, instead of an 8x in the middle term, you write it as a 2x and a 3x. Then you can group that, take the first two terms. We can take an x out of the first two terms. We can take a 2 out of the second two terms. So if we factor out 3x plus 2, that's in both of those terms, 3x plus 2 times x plus 2, which that's what's left. So this is all reviewing stuff. Sums are difference of cubes. If you have a to the third plus b to the third, that factors to a plus b times a squared minus ab plus b. So we'll be reviewing all these things that we're going to use. And so a lot of that we may have to look up. We may not remember all of that because there's a lot of different factoring techniques that are looked at on these 6 steps right here. Let's go to page 3. Using skills on rational expressions. So simplifying rational expressions is the same as simplifying fractions. You got to find the factors of the numerator and denominator. So we have a video here. How long is it? No, don't get started yet. I haven't got you ready. 3.5 minutes. Let me present that in a manner in which you can actually hear it.
Okay, we're going to look at some rational functions here. What is a rational function? Well, it's a function that's in the form of a ratio or a fraction. It's got a polynomial in the numerator, another one in the denominator. Sometimes, though, we can take these and simplify them a bit so that we don't have quite as much to deal with when we're trying to figure out some of the features of this function. So in this case, I don't see much I can do at the top right at the moment. At the bottom, it looks to me like I can factor an x out. So if I take out an x, I get x times x plus 2. Well, now I see that I can cancel this x with one of the ones in the top. So once I do that, I have 5x over x plus 2. I think that's as far as we can go, but that definitely looks a little better than it did before. Let's look at another function. This one's a little more complex. It is x squared minus 9 over x squared minus x minus 6. Now I notice that the top is difference of two perfect squares, so that will factor easily. That's x plus 3 times x minus 3. In the denominator, with a little checking, I find I can factor this as x minus 3 times x plus 2. Now I see I have a common factor of x minus 3 that I can take out. And now this leaves us with x plus 3 over x plus 2. And that's certainly simpler than it was before. Let's take one more. Let's take f of x is equal to 3x cubed plus 18x squared plus 27x, all divided by 12x squared minus 48. Okay? In the top, it looks to me like I can take out a 3x from each term. So 3x times x squared plus 6x plus 9. Now on the bottom, I believe I can take a 12 out. And so I get 12 times x squared minus 4. Now I notice this is actually a perfect square, and this is difference of two perfect squares, so I'll be able to factor those pretty easily. So we get equals 3x times x plus 3 times x plus 3 all over 12 times x minus 2 times x plus 2. Now I actually don't see any of these that will cancel. I do see over here in my coefficients, though, that I can take a 3 out of each of those. So let's go ahead and do that. And we get x times x plus 3 times x plus 3, all divided by 4 times x minus 2 times x plus 2. And maybe this didn't cancel very much, but we've simplified it as much as we can, and we've got it in a form where we'll be able to do some more things with it.
All right. So that is a look at what we're doing, simplifying rational expressions. So let's look at this first example. And I'll do a lot of these on paper so we can build some notes up. 3x plus 6 over 6. 3x plus 6 on top would factor to be 3x plus 2, right? Because 3 times x is 3x, 3 times 2 is 6. And on the bottom, we can factor 6 to be 3 times 2. So now you've got 3 divided by 3, which is just 1. They cancel each other out. So this will simplify, just be x plus 2 over 2. Now, you might think, well, can't I cancel these out? Well, they're both being that. You can rewrite it. It really doesn't simplify it. It could be x plus 2, x over 2 divided by, plus 1, I mean, because this would be x divided by 2 and 2 divided by 2. You have to divide every term by what's on bottom. So this isn't really simplifying it. It's just a different way to write it. We generally would prefer just leaving it like this. But this is the same thing. So not necessarily simplified, just a different way to write it. This is definitely simplified because we canceled the 3 out of it. So I would generally leave it like this, but you may see a textbook or some assignment in Buzz where they do this and just realize that's the same thing. Those are identical. So, and they leave it as the x plus 2 over 2. See, they didn't simplify it to the x divided by 2 plus 1. That's just a different way to do it. Okay. Important note. Oh, that's what I was just talking about. A common thought is that the 2 in the numerator and the 2 in the denominator can be canceled out as well. But the numerator is connected to an x. You have the x plus 2. It's not just a 2. And the big line indicates division. So division cannot undo addition or subtraction, only multiplication. So since these are being added and not multiplied, we can't divide it by the 2. Terms can't be separated, just factors. So factoring is needed. So that's what I said. X divided by 2 plus 1 is just a rewriting. It's not a simplification. So I would leave it in this form right here. Restrictions. Okay, let's talk about this. I'm going to write this one down. Let's talk about why there would be restrictions on a rational expression. So looking at this rational expression right here. Now, right off, I'm thinking, okay, well, this isn't going to simplify in any way because this is just 4s and x plus 2 minus 2 when we get there, 3x. I don't see anything that's going to cancel out. But there are restrictions on this. Can you think of any possible x that would not be allowed for this rational expression? Like, okay, x can't be 1. Okay, well, x can be 1 because that would be 4 times 1 squared, which is 4. It would be negative 12 divided by 3. That'd be negative 4. So 1 is allowed. But can you look at that and think any x that would not be allowed? I'll give you a moment to think about that. And I'm going to say x cannot be, and there is an answer. If you think about it in the fact that what is a fraction? A fraction says we're going to take 4x squared minus 16, and we're going to divide it by 3x. This means divide. That's what a fraction means. It means divide. Like when we have 1/2, it really means take 1 and divide it by 2, and that's the same as 0.5. Because if you take 1 and divide it into half, divide it by 2, that makes it just 0.5. So we are dividing. So if we're dividing 4x squared minus 16 by 3x, what x would be illegal, we'll say, in math? Not allowed, undefined, whichever term means the most to you there. Oh, Daniel's on to something. Yes, what's the only number in mathematics that we're not allowed to divide by? X cannot be 0. 3 times 0 would be 0, and that means we're dividing whatever this is by 0. Can't divide by 0, so the universe explodes. No, I'm just kidding. It's not that drastic, but it's not defined. There's no way to divide something by 0. So on something like this, we would have a restriction. Okay, it's 4x squared minus 16 over 3x, but x can't be 0. X can be anything else. That's fine. Cannot be 0. So sometimes you'll be asked about the restrictions on that, and it's anything that would make the denominator 0. Anything that would make the denominator equal 0, which in this case is only one number. 0 is the only number that would make this equal to 0. If this is 1/3, that'd be 1. 3 times a third is fine. It's just anything that would make the denominator 0 is what we're restricted and cannot have. So yeah, if x equals 0, then the denominator 3 times x would be 3 times 0, which equals 0. And the most absolute thing in math is you cannot divide by 0. So that is a restriction. All right. Oh, got another good one for us to simplify here. Let me get this. X squared plus 5x plus 6 divided by x squared plus 4x plus 4. Okay. So this unit's going to give you a lot of practice on your factoring skills. If you're a little rusty at factoring, this is the time to do that. So x squared plus 5x plus 6. You remember how factoring works? This is just an x squared. There's no coefficient. So we're just finding factors of 6 that multiply together to be 6, but they add together to be 5. This is multiply. This is add. So 6 is pretty simple. There's just 1 and 6 and 2 and 3. That's it. And since this is a positive, these could both be positive or negative, right? Could be -2 times -3 or -1 times -6. The way we know is looking at that middle term. We need them to add together to be a +5, not a -5. So obviously it's 2 and 3, and it's positive. So 2 and 3 are the factors. So this factors to x plus 2 and x plus 3. Because if you multiply those back together, you'll get this. So we can rewrite the top as x plus 2 times x plus 3. And then the bottom phrase, x squared plus 4x plus 4. Looking again at the 4, two numbers that would multiply together to be 4 and add together to be 4. So that must be 2 and 2, right? 2 and 2 multiplies and adds there. So this factors to x plus 2, x plus 2. So we could rewrite that. So when we want to simplify that, well, we got x plus 2 divided by x plus 2. That equals 1, right? X plus 2 divided by x plus 2. So these are different. So this equals x plus 3 divided by x plus 2. That's what this simplifies to. We were able to take an x plus 2 out of the top and bottom. Look how they worked it on their example there. So they factored the x plus 3, x plus 2, x plus 2, x plus 2. Oh, the restrictions can be found now. So what is the restrictions to this? Because we didn't calculate that. Looking at this, it may be harder to tell what the restrictions are. Looking at this, now we can tell x cannot be, well, even from this, they're the same number. X cannot be -2 is the restrictions. Because if you put -2 in there, this will equal 0. Let's prove that to ourselves that this is also that. So -2 squared plus 4 times -2 plus 4. -2, that's a terrible 2. -2 squared, -2 times -2 is a positive 4. 4 times -2 is a -8 plus 4. Yep, that would equal 0. Hard to look at that and figure out what the restrictions are, but when we factor it and we see x plus 2 times x plus 2, that means x can't be -2. And then we can simplify it from there. But that helps us figure out the restrictions when you factor it and get it down to just the x term. Before we simplify it, the factors are both x plus 2, so you can just say x plus 2 equals 0. What would that number be? X equals -2. So that is a restriction. And then simplify it down to x plus 3 over x plus 2. All right, let's look at page 4. Oh, and that's the lesson summary. Okay, we have a video, but if you have a piece of paper handy, I want to give us a chance to kind of work through this before we watch them work through this. X squared minus 12x plus 32. And this is going to be divided by x squared minus 7x minus 8. Okay, let me put this up on the screen. If you have a pencil and paper, this would be good for you to work too. But where are you going to start? We'll go through this one slowly. Give you a chance to think about it. Give you a chance to give some input. Where do you want to start with this? Now, we can either start with the numerator or denominator, by the way. It doesn't really matter. We have to do them both. But we need to factor this polynomial and factor this polynomial. Okay, so x squared minus 12x plus 32. Okay, this is going to factor to what? So that's what we need to figure out. It's obviously going to be an x and an x because those multiply to be x squared. The second number is going to multiply together to be 32, but it's going to add together to be -12. Going to multiply to be this, going to add together to be this. All right, see if you can figure out what the factors are, what numbers go right here that will add together to be -12, multiply together to be positive 32. So I'm going to give you a minute to look at that. Think about it. If you got a pencil and paper, you might be writing it down, trying to figure out what numbers that would be. Just good practice. So we're going to do a lot of that this unit. Factoring. If it helps you, start with the factors of 32. What all multiplies to be together in 32? 1 and 32, -1 and -32. Because we can multiply -1 times -32, and that's positive 32. But neither one of those add together to be -12, so keep going from there. Next, I would say 2 and 16 will multiply together, or -2 and 16, but both negative, because that would multiply together to be 32. But again, if we add those, 2 plus 16 is a positive 18. -2 plus -16 is a -18. That's not going to be it either. Got to keep going. Anyone got it yet? There's still more factors of 32. All hope is not lost. Not yet. Daniel says 4 and 8. Or it could be -4 and -8, because negative times negative or positive times negative. I mean, positive times a positive. So this would multiply together to be 32, and it would add together to be 12. So this adds together to be -12. Ah, bingo. That's what we're looking for. -12. So this is going to be x minus 4, x minus 8. So on top, we can rewrite that to be x minus 4 times x minus 8, because that's the same thing as this is. We factored it. Now factor this. X squared minus 7x minus 8. All right. Which means it's going to multiply together to be -8, add together to be -7. So this is going to be x something. Well, here's what I know. Since it's going to multiply to be a negative, one of these has to be a positive and one of them has to be a negative, because that's the only way we can get a negative number. You have to multiply a positive times a negative. So we know it's a plus minus situation. Just which numbers are we going to use? Multiply together to be -8, add together to be -7. Coefficients of 1, so we can just use the -8. It could be -1, +8, could be +1, -8, 2 and -4, -2 and +4. That's about it. I can't think of any other numbers that would multiply together to be -8. We need them to add together to be -7. -1 and 8 is a +7. 1 and -8, hey, that's a -7. This is a -2 and a +2 down here. So we need 1 and -8. +1, -8. So we can now rewrite this as x plus 1, x minus 8. What's our restrictions? What's our restrictions? Tell me any restrictions that's on our equation, which started out as this, but looking at this, it's like I have no idea. But now I've got it to this. Put in the chat any restrictions to our rational expression. Daniel says 8. Mary says, hey, 8. Can't be 8. All right, I've got 3 people that said x cannot be 8. Anyone see anything wrong with that? Everyone agree with that? Anything you want to add? I will say you're half right. And no, I don't mean 16 instead of 8. I'm just saying you've only given me half the answer. X cannot be 8. Or -1. Yeah, Ava's got it. See, if x is -1, -1 plus 1 times -1 minus 8. That's fine over here. This is -9, except for I'm multiplying it times 0. So it's still going to be 0 if this is -1, because this becomes a 0. Because anything that would make this 0 would make either one of these 0. So it can't be 8 and it cannot be -1. X minus 8 cancels out. So this is just x minus 4, x plus 1. And I really don't have to put the parentheses since it's not being multiplied by anything. If, this is a good warning right here, if we simplify first, we might miss this 8. Because when I look at this, the only restrictions here is -1. But if I look back here, which is before I've canceled anything out. So I want to show you something, and this is kind of looking ahead to another week. I'm going to put this up here. We're going to look at Desmos real quick. Let's put the x minus 4, put that parentheses when I graph it, divided by x plus 1. Okay. Look what happens with the graph of x minus 4 over x plus 1. Goes up and down, but we said it can't be -1. Look, here, let's put the line x equals -1. There's the line x equals -1. Look at that. It's an asymptote. Up and down. The graph does not equal -1 because that would be dividing by 0. So we get one of these funny graphs. But let's put the full equation in, not just the simplified. Let's put the entire thing in. The x squared minus 12x plus 32. All of that in parentheses. Divided by x squared minus 7x minus 8. You're like, okay, I see that -1 thing. See the -1? That asymptote. But what happened that we said x can't be 8? Look at that. You're like, yeah, Desmos is tricking you. Desmos is tricking you. You're like, what? What do you mean Desmos is tricking me? What's this? Okay, here's the graph for 7.4, 7.5. Getting close to that 8. It's not supposed to be there. Oh, look, did you see that? There's a hole in our graph. It's undefined when x equals 8. You wouldn't see that just by graphing it. This one you see the x equals -1, but you don't see the 8. And I can let you in on the secret right now because we'll study this in later weeks. The reason you do not see the 8 is because it's simplified out of our graph because it's on top and bottom. If it's on top and bottom, it's just a hole in the graph. If it's just on the bottom like this, it's an asymptote. But since it exists in both places, it's actually a hole in the graph. That's why it's undefined only at that one point. It exists at 7.999. It exists at 8.0001. It does not exist at 8. Little interesting tidbit that we will talk more about in future weeks. All right, let's look at their little video that also describes this and see if they did something we didn't.
The first step in simplifying a rational expression is to factor the numerator and the denominator, if that is possible. In the given expression, both the numerator and the denominator are trinomials that can be factored into two binomials. Begin with the numerator. The numbers that multiply to 32 and sum to -12 are -4 and -8. Therefore, the numerator factors into x minus 4 times x minus 8. Now factor the denominator. The numbers that multiply to -8 and sum to -7 are 1 and -8. Therefore, the denominator factors to x plus 1 times x minus 8. The next step is to identify the restrictions on x for this rational expression. To do this, set the denominator equal to 0 and solve for x. When x equals -1 or 8, the denominator equals 0. Therefore, x cannot equal -1 or 8. The final step is to simplify the fraction by canceling any common factors. Both the numerator and denominator have the binomial x minus 8 in common. These factors may be canceled. Leaving the simplified rational expression x minus 4 over x plus 1. So the simplification of the given rational expression is x minus 4 over x plus 1, where x is not equal to -1 or 8.
All right.
You have 9 weeks at Patrick. Let me hear.
That's the same answers we did. I guess we did right. We got to come up with the same thing. Let's look at this. Example 2. So simplify this completely, identify any restrictions. So they're doing it step by step here for us, but we'll go ahead and instead of stepping through all theirs, we'll put it on paper so we got it in our notes. We're going to start another sheet of paper for this one. Sharpen this pen. So let's start with the top, and let's break this out as much as we can. So 2x squared plus 30x plus 88. What's your first step? What's the first thing you're going to do with this? That is a 2.
Oh,
We're going to factor it. So what's our first step in factoring? Always, really. Step number 1. Step number 1. Anyone remember what step number 1 is in factoring?
that's like the count I'm carrying around like this. Like
I'll give you a hint. G, C, F. We find the greatest common factor. Yep. You guys are on it. So 2x squared plus 30x plus 88. Well, the only thing I see that they all have in common is a 2. So let's factor that out. 2x squared plus 15x plus 44. Okay. And now, can we factor that? Can we find numbers that multiply to be 44 but add to be 15? So 44 is first 1 in 44, and it could be the negative versions, but since this is a positive, we really know it's going to be positive numbers because it'd have to be a negative times a negative, and that would add up to be a negative. So let's just look at the positive numbers because these are all positive. 1 in 44, 2 and 22. There's not a 3. There's a 4 and 11, 5, 6, 7, and that's it. That's the only factors of 44. So these add together to be 45. These add together to be 24. Hey, these add together to be 15. Ding, 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 ding. So this is 2 times x plus 4 times x plus 11. That looks to be as small as we can possibly factor that. Because multiplying together to be 44, 4 times 11, add them together is 15. That's our number. So this is going to equal 2 times x plus 4 times x plus 11. Wonderful. Now let's take the bottom. 2x to the third plus 7x squared minus 4x. And again, greatest common factor. Well, we got a 2, a 7, and a -4. So those we can't do anything with because 7 is not going to be the same thing. But look here. We can factor out an x because they all have an x. That makes it 2x squared plus 7x minus 4. Now, in this one, we have a coefficient. So we don't just look at the factors of -4. We have to multiply it by the coefficient. See, when we had x squared, it's just a coefficient of 1, so it's 44 times 1, so we don't worry about that. But with -4, this is factoring by grouping since we have a coefficient. -4 times 2, we're looking at the factors of -8. They're going to add together to be a +7. So this could be -1 and a +8, or a +1 and a -8, or it could be a 2 and a -4, or a -2 and a +4. Right? That's all the factors that can multiply together. And when we add those, we see -1 plus 8 is 7. That's what we want. So now we take this and we factor by grouping. 2x squared, and I'll put the 8 with that. No, I'll put the 1 with that. Minus 1x plus 8x minus 4. Yes, Daniel.
So why is it 8? I missed that part.
Okay, good question. Because when you have a coefficient in the front, you have to multiply those numbers together. The reason we didn't here is because the coefficient's a 1. So 1 times 44 is just 44. We generally don't talk about it if it's just x squared because it's assumed a 1. So we do it in our heads. We just don't mention it. We probably should mention it every time, and then it won't be surprising when we get one of these. Coefficient of x squared is 1. 1 times 44 is 44. But this one, since we have a coefficient, I'm sorry, it's actually this one, no, because we're doing the x squared. I didn't mean to highlight the x third, but the 2 and the -4 have to be multiplied together because there's a coefficient out front. So then we can rewrite the 7x as a -1x and a +8x. Right? We understand that. We did not change the 7, we didn't change the 7x. We just rewrote it as a -1 and a +8. Now we can factor by grouping. So this is x times 2x squared minus x. That's another x. And when we factor it out, we get 2x minus 1. So that goes from 2x squared minus 1x to just x times 2x minus 1. Over here, we've got a positive x, 8x, and a -4. So it looks like the only thing that factors out of that is a 4. So this is 2x. 4 out of -4 is 1. Now when we look at this, and all of that is being multiplied by this x way out here. So now we've got x out front. Inside the parentheses, we've got x times 2x minus 1 plus 4 times 2x minus 1. So 2x minus 1 can be factored out. And what that leaves is x plus 4. So it all factors down to x times 2x minus 1 times x plus 4. When we got it all factored out, breaks out to that. This is when we need to stop and get our restrictions. Because after we simplify it, we may miss something. So x cannot be what? All right. I'm going to let you put that in the chat. Give you a minute to think about that. Anything that would make this expression 0 is what's not allowed. Anything x times 2x minus 1 times x plus 4 equals 0. This is what's going to be banned. So you have to figure out what numbers that would be. Let's see what you come up with. Give you a moment to work that, put that in the chat. I'll give you a hint. There's 3 numbers x cannot be. 3. Some of y'all just went, whoa, 3? Yeah, there's 3. We're almost down to a fully simplified, but we got to find the 3 answers of what x cannot be. Okay, Daniel's got a couple of guesses. He's not sure about the third one. Yeah, third one is the one that we don't think about all the time. Anyone else got a shot at it? And I wrote this down here on purpose because this is really the best way to figure it out. If we have x times 2x minus 1 times x plus 4, solve for x for what would make that 0. And when we have it down in factored form, we just take each of the factors. So that means x equals 0 would make that 0. Or 2x minus 1 equals 0 would make that a 0. Or x plus 4 equals 0. If any one of those 3 are 0, since they're all 3 being multiplied together, if any of those are 0, then we're in trouble. X equals 0. There's the first one. 2x minus 1 equals 0. Solve for x. So 2x equals 1. Divide by 2. If x equals 1/2. Or subtract 4 from both sides. X equals -4. That is the 3 x's that we cannot have. 0 would make this one a 0. If it was 1/2, 2 times a half is 1. 1 minus 1 is 0. Half would make this 0. And -4 would make this 0. So anything that makes any one of these factors 0 would make all of it 0 since they're being multiplied together. Now we can simplify. There's an x plus 4. There's an x plus 4. Nope, we can't take the 2 out of here because it's connected to other things. So it's going to be 2 times x plus 11 over x times 2x minus 1. This is what it simplifies down to. This is what it cannot be, the restrictions. Let's see what they did with that. Okay, so they walk through the steps. What's the greatest common factor of the numerator? Well, we pulled a 2 out. Yes. All right, what's the new expression in the numerator once it's been factored? Well, then it's 2 times, what we factored out to? X squared. Well, they already put the squared on for us, x squared. And then we had 15x, and we had 44. Yep. And then it said, after you factor that, what do you get? Well, we had x plus 4, and we had x plus 11. Then they're going to switch and say, what's the greatest common factor denominator? That was an x that we pulled out. Yep. And then what's the new expression once you pull the x out? It's x, and it is 2x squared, which they've already put the squared on for us, and then 7x and minus 4. Oh, try again. What did I miss? 2x squared plus 7x. Oh, they already put a minus. Okay, they already put a minus there. That's why I didn't want. They put the minus for me, so they just want me to put the 4. And let's see, factor the trinomial. What's the new expression in the denominator? That was the 2x minus 1 and the x plus 4 times the x out front. That was step 1. Step 2, find any restrictions. So fractions have to be entered as a over b. So we said x cannot be 0, x cannot be 1/2, and it could not be -4. Excellent. Yeah, see, that was the x equals 0, 2x minus 1 equals 0, or x plus 4 equals 0. And then their third step, simplify the factor expression by canceling common factors. Select the factor that cancels. Well, the x minus 4 cancels with the x minus 4. And that's it. So the answer ends up 2 times x plus 11 times x times 2x minus 1, where x can't be 0, 1/2, or -4, which is what we got. If you want another example, more practice, they have one right here. Simplify x squared plus 6x minus 27 divided by x plus 9. So when you factor that, you can check it right here. It's x minus 3 minus x plus 9. Can't have a -9. And it simplifies to just be x minus 3. But still, x cannot be -9. Lesson summary. How can rational expressions be rewritten in a simplified form? You factor the numerator and the denominator, if possible. May not always be factorable. Identify the restrictions at this point before you simplify. Because if you simplify it, it's just x minus 3. There's no restrictions on x minus 3. But x can't be -9 because there is an x plus 9 that is originally in the denominator. Okay, let's look at some practice problems here. Drag the statement to the correct reason. 2 of the statements are incorrect. Oh, I like this. Okay, so given, factor numerator, cancel out factors, simplified with restriction. So they want to know given, what means, what's the original problem? Well, the original problem would have to be this one where no factoring has yet happened. All of these have some form of factoring. So it wants to factor the numerator because the denominator is x minus 7. There's no factoring to do there. So it has x squared minus 8x plus 7. So it looks like, well, that would have to be this because this is cancel out factors. So we haven't got to canceling out factors yet. So what cancels out? Well, obviously the x minus 7. But let's see what are they doing here. Oh, be careful and look at this. On this one, they're canceling out x minus 7 on the numerator and denominator. On this one, they're only canceling the minus 7. This one, they're only canceling the x, but they're canceling out all 3 x's. That's not how that works. It has to be this one, where you're canceling out the entire x minus 7 on the top and bottom. You can't take out part of it with just like all the x's. Can't just do the -7s because they're attached to that x. So the answer just ends up x minus 1. So that's pretty good. Here's another one. I won't do this one. I'll leave that for you to practice on. But it's very similar to what we just did. Like that. Next page of practice. Simplify each. Here's 5 problems to do right here. And check your answer. This one's pretty simple because the bottom's just a 6. If the numerator is just a 6, there's no restrictions, right? There's no possible way that you could divide by 0 because there's no x in the denominator. So this one, you simply factor the numerator and see if anything cancels out with the 6. Spoiler alert, yes, something's going to factor out, but it's going to partially. See, 9 over 6 cancels to 3 over 2. You just simplify it to 3 halves. Let's see this one. Let's do this one together. We got a few minutes of class time left and haven't. What did I do with my pencil? My pencil ran away. Oh, there it is, hiding behind my keyboard. So I'm going to write this one down. K squared Okay, so let's see. We know the top k squared minus 3k minus 18. So this is going to factor to k something, k times k, because that's k squared, so k times k. So we need two numbers that multiply together to be negative 18, but add together to be a negative 3. So that means one of them's going to be a positive and one's going to be a negative because we end up multiplying together and getting a negative. So let's see, 18 times 1, that's not going to add together. 9 and 2 wouldn't do that either. 6 and 3, 6 and 3, if it's a positive 3 and a negative 6, those would add together to be a negative 3. So that's going to be the numerator, 4k plus 12. Well, that's just 4k plus 3. The only restriction is x cannot be k plus 3. X can't be negative 3. But that's the only number that would make this 0. And this would just cancel out the k plus 3's. So the answer is k minus 6 divided by 4. That was not too bad. Let's see what they got. K minus 6 divided by 4. K cannot be negative 3. All right, so they got 5 problems for you there to practice. Let's go look at our assignment. Simplify completely. Notice there's no restrictions on this one because the denominator is just an 8. So it doesn't need restrictions. They didn't ask you the restrictions here, but this one has restrictions, right? But simplify completely. If you simplify this, what are we going to end up with? Here's another one. Simplify completely. This one says simplify and find the restrictions. So you have to simplify it and then find the restrictions. So looks like it's either going to be 12 over x minus 7 or x plus 3 over x minus 7. And it's going to have 1 or 2 restrictions. And same thing on number 5. Simplify completely, find the restrictions. Not too bad, 5 problems. This is good practice because we're going to get deeper into rational expressions. So the first thing we really need to know how to do is how do we simplify it? How do we make it just as simple as possible? So that's how we do it. Any big questions? I know once you get in there working, you may get some more questions, but if you didn't practice them during class, you may struggle a bit more because the best way to make these easy is to practice them. And the more you do, the more it's like, oh yeah, that's right. This would factor this way. That's going to cancel. All right. Oh, x can't be 0. X can't be negative 2, whatever it is. So practice these and they get easier and easier and easier. That's the best thing I can tell you about them. So, all right, guys. We got a few minutes left before 4th hour, if you have a 4th hour. So you may be able to at least get started on some practice problems if you hadn't already practiced. Or if you had, you may be ready to jump in and start the lesson. Remember, if you start and don't have time to finish, save and exit will save all the work you've already done. Buzz does allow you to jump out in the middle of the assignment and not lose where you were and have to start over. That's the good thing. So, otherwise, that's all I got for you. I don't see you again this week. It is an A-Day Friday, so I'll be here Wednesday and Friday. So regardless of what your grade is, if you're struggling with this, it's like, man, I'm not getting it. I'll be here Wednesday and Friday. Come see me. We can do some of the more of this together and get you where you're in good shape before spring break next week. If I don't see you again this week, we'll see you. Have a great spring break. I'll see you in 2 weeks. So, all right, guys, that's it for today.